Good morning, students. Today, let us start a new lesson. Lesson number 4, Effects of Electric Current from Science 1. Okay, so let's begin. So we will learn today energy transfer in an electric current. Let us perform an activity to understand the concept clear. To perform this activity, we will require a voltmeter, an ammeter, two electric cells of 1.5 volts each, electrical resistance having value of 1 ohm, some connecting wires and a plug key. So children, let us start now with this activity. First, we shall connect the circuit as shown in this circuit diagram. So children, let us now put the plug in the key. What do we observe? As soon as we plug in the key, there is a deflection in ammeter as well as in voltmeter. So let us first note down the value of current, that is I. It is 0.3 ampere. The voltmeter shows the value of 3 volts. That means the potential difference, that is VAB, between the two ends A and B of the resistance is 3 volts. The potential at A is higher than the potential at B, as the point A is connected to the positive electrode of the cell and point B is connected to the negative electrode of the cell. If a charge Q flows from A to B, then the work done Q while going from A to B can be calculated by using the formula. Potential difference between 2 points is equal to the work upon total charge transferred. Let VAB be the potential difference between 2 points A and B. Thus, work done while going from A to B is equal to VAB multiplied by Q. Do you know from where does energy come to do this work? Yes, you are right. The energy comes from the cell connected in the circuit. The cells gives the energy through the charge Q to the resistance where work VABQ is performed. if the charge Q flows from A to B in the time t, then during that time the energy VABQ is given to the resistor. The energy received by the resistor is converted into heat energy, due to which the temperature of the resistor is increased. Let us now study the expression of electric power from the earlier circuit. Electric power is the energy per unit time converted by an electric circuit into another form of energy. Electrical power is denoted by the letter P. So, P is equal to electrical power, which is equal to energy divided by the time required, which is equal to VAB into Q upon T. Since Q upon T is equals to I, therefore P will equal to VAB into T into I. Let this be the equation 1. The source of energy, the cell, gives in time t the energy P into I to the resistor. If I is the current flowing continuously through the circuit, the heat produced in the resistor in time t will be H is equal to P into T. Therefore, H is equal to VAB into I into T. Let this be equation 2. Now, according to Ohm's law, VAB is equal to I into R. Let this be equation 3. Therefore, H is equal to VAB square into T upon R. Let this be equation number 4. Similarly, H is equal to I into R into T. Therefore, H is equal to I square into R into T. Let this be equation number 5. So, H will equal to I square into R into T, which is known as Joule's law of heating. Joule's law states that the quantity of heat H generated in a conductor of resistance R when a current I flows through the conductor for time t is directly proportional to the square of the current resistance of the conductor and the time for which the current flows. Got it? Good. So children, have you understood the Joule's law of heating? Okay, let's move ahead. Now children, come, let us learn about the unit of electrical power. As seen earlier, in our electrical power, it is given as P is equal to VAB into I. That is equal to volts multiplied by amperes. Let this be equation number 6. Now, 1 volt is equal to 1 joule upon 1 coulomb, and 1 ampere will be 1 coulomb upon 1 second. Let this be equation number 7. Now on multiplying, we get 1 joule upon 1 second is equal to 1 watt. Isn't it? Let this be equation number 8. Thus, the unit of electrical power is 1 watt. Okay, children? The unit of electrical power is 1 watt. Now let me ask you some questions. If in the circuit shown earlier, the resistor is replaced by a motor, then in which form will the energy given by the cell get transformed into? Yes, children? Can you tell me? Yes, you are correct. The electrical energy will get converted into mechanical energy. So, the unit of electric power is 1 watt, isn't it? We have just learned. So, can we write mechanical power in a manner similar to the electrical power? Yes, mechanical power is the rate of doing work or work done per unit time. So, mechanical power will equal to work done upon the time required. Got it, children? So let us learn about the heating effect of electric current. Okay? We know that in a cell or a battery, chemical reaction takes place and converts into electrical energy. This energy sets the electrons in motion to flow the current through a resistor connected to a battery. The source has to keep expanding its energy in a circuit to maintain the current. Right? So, where does this energy do? A part of the source energy may be consumed into useful work, like in rotating the blades of an electric fan, and the rest of the source energy may be expanded in heat to raise the temperature of device. On the other hand, if the electric circuit is purely resistive, the source energy is converted into heat. This is known as the heating effect of electric current. This effect is utilized in devices such as electric heater, electric iron, etc. Now consider a current I flowing through a resistor of resistance R, and a potential difference is across it will be V. Let T be the time during which a charge Q flows across. Now, the work done in moving the charge Q through a potential difference V is VQ. Therefore, the source must supply energy equal to VQ in time T. Okay? Hence, the power input to the circuit by the source is P is equal to V Q upon T, that is equal to VI. I, since it is Q upon T is equals to I. So the energy supplied to the circuit by the source in time t is power multiplied by time. That is E is equals to P into T, or E is equals to VIT, since P is equals to VI. Are you understanding, children? So what happens to this energy expended by the source? This energy gets dissipated in the resistor as heat. Thus, for a steady current I, the amount of heat produced in the time t is H is equals to VIT. Let this be equation 1. Now, according to Ohm's law, V equals to IR. Substituting this in equation 1, we get H is equals to IR into IT. So, children, H will equal to I square RT. This is Joule's law of heating. Now, according to this law, heating produced in a resistor is first directly proportional to the square of the current. Second, directly proportional to resistance for a given current. Third, directly proportional to the time for which the current flows through the resistor. Understood, children? So, let's take a look at the summary. Energy transfer in circuits. Energy cannot be created or destroyed. In all devices and machines, including electric circuits, energy is transferred from one type to another. When this circuit is connected, chemical energy stored in the battery is transferred via electrical energy to heat and light energy in the bulb. So the total amount of heat and light energy is same as the amount of chemical energy from the battery. When this circuit is connected, chemical energy stored in the battery is transferred via electrical energy to heat and light energy in the bulb. The total amount of heat and light energy is same as the amount of chemical energy lost from the battery. Measuring current. The unit to measure current is the ampere, which has the symbol A. Current is measured using a device called ammeter. In a circuit diagram, an ammeter is shown by the symbol A. When measuring the current through a component, the ammeter is always connected in series, that is, in the same loop with that component. Measuring voltage. Voltage is measured using a device called voltmeter. In a circuit diagram, a voltmeter is given by the symbol V. When measuring the voltage across a component, the voltmeter is always connected in parallel with, that is, or across the component. The voltage supplied by the battery is shared between all the components in a series circuit. Heating effect. When electric current passes through the conductor, heat is produced. Larger the current, more is the heat. So the change of electrical energy into heat energy is called heating effect of electric current. The heat is generated in a resistor or a device when current flows through it. The real-time examples is when we switch on bulb, current passes through it and it becomes hot. The heating effect of current has its application in electrical heater, geyser, press, etc. So children, we have finished our today's session. Isn't it was a interesting topic? Yes. So we shall see you in the next video with a new topic. Children, please do read your textbook, your lesson number 4, and read it thoroughly and understand. So we shall see you in the next video. Till then, take care children. Thank you very much.